Okay, so let's go to part two of this revision of factorization. So what's happening? Well, the key to this, the 3D, okay, fully factorized. Let's look at the first section. Okay, basically you're pulling out what each term has. Here's a term, x squared x. What do they share? Well, they share an x. If I pull out the x, that leaves me x and then minus 5, okay? Because x times x is x squared, x times negative 5 is negative 5x. What I've done is I've factorized. I've pulled what they have in common, okay? Let's look at g, okay? We have x cubed plus x squared. What do they have in common? Well, they have two x's in common. I can pull out two x's. What does that leave me with? X plus 1, right? Because x squared times 1 is x squared. Okay. Let's look at h. We have 3ab squared minus 9a squared b. Okay. What do they each have in common? Okay. I can see they have 3 in common, right? Because that's a 3, and obviously 9. 3 goes into 9. They have an 1a in common. This has 1a, that has 2 a's, but I can pull out an a. And then I have a b. What does that leave me with? 3a. That leaves me with just a b there, right? Minus 3 times 3 is 9. And then what's left here? I pulled out 1a, so that left me this a. The b's been pulled out completely. So there you go, 3ab times. Okay, so let's look at the next section. The next section, for example, a, we have 3x plus 5 plus x, and then x plus 5. Okay. This really is one term here. This is another term. Okay, they're being multiplied. So what do they each have? They each have an x plus 5. So if I pull out x plus 5, what's left here? The 3, right? Plus, if I pull out the x plus 5, what's left here? X. Okay, and I can rewrite that. X plus 5 times x plus 3. Just like that. All right. I know that at times it looks complicated, but really just need to think, what do they have in common? And also look at section 3. A lot of these are going to be your perfect squares. Okay, x squared minus y squared, right? Okay, perfect squares. So that would become x plus y, x minus y. Where does that apply? Well, look at 3a. You have x squared minus 16. Okay, x plus 4, x minus 4. Right? Because x squared minus 16, 16 is the same thing as 4 squared. Difference of two squares. See? Difference of two squares. X squared minus y squared. Well, there's your y. So that becomes x plus y, which is x plus 4, times x minus 4. All right. How about, for example, let's look at j, I guess, j. So we have x plus 3 squared minus 4. So that's x plus 3 squared minus what? 2 squared. The difference of two squares. Okay. So that is difference of two squares. X plus y, x minus y. In this case, x is x plus 3. So we have x plus 3 plus y plus 2 times x plus 3 minus 2. Now we can combine. That becomes x plus 5 times x plus 1. Okay? Alright, let's try another one. Alright, let's see. Fully factorize looks at section 5. Okay. Now some of these they just go back to your rules. Alright. We have x squared plus 4x plus 4. Okay, well that is, if you remember, you have a plus b, a plus b squared so x plus a plus b squared is what? A squared plus 2ab plus b squared. Okay, what does that mean for here? Alright, well, you can factorize it. You can think in reverse FOIL, and you could say, alright, well, what are the factors of 4 that add up to be 4 here? 4 and 1, but 4 plus 1 is 5. 2 and 2, yes. So that becomes x plus 2, x plus 2, which is x plus 2 squared. Okay? It's like the opposite of what we were doing before. If you have, for example, let's look at 6. 2x6, 3d6. It's number d. Right, so if you have 2x squared minus 50, what can you do first? Well, let's take out the 2 from both. 50 divided by 2 is 25. Now, can you see what this is? Can you see that this is difference of 2 squares? This is x squared minus 5 squared. And the difference of 2 squares looks like x plus 5, x minus 5. Right? Difference of 2 squares. Right? So factorization, this is what we're doing. Now some of them, let's say 6f. It looks, you're thinking, oh wow, this looks hard. This looks hard. We got a negative 3 in front. I don't know what to do with that. Okay, well how about this? Each of these coefficients, or in this case it's a constant, each of these numbers, negative 3 goes into it. So we could pull out 3, but let's pull out negative 3. That leaves me with x squared negative 18 divided by negative 3. Use a calculator if you don't remember. That becomes a positive number, and this is a positive 9. Right? Negative 3 times positive 9 is negative 27. Okay, then what does that look like? Whoa, what do you mean? Well, x squared plus 6x plus 9. You can do the factors. What are the factors of 9? And it needs to add up to be 6. It is 3. Right? They multiply to be 9, and they add to be 6. So that is the same thing as x plus 3 times x plus 3, which is x plus 3 squared. Okay?